Hello everyone, so welcome to my video. For today's video, I'll be sharing with you another program in which I'll be implementing the selection algorithm and the merge sort algorithm. So as the name suggests, we are going to tackle about, or we're going to do a program about sorting. Okay, when we say sorting, it's about arranging the elements of an array in a particular order, in increasing or in decreasing, or in non-decreasing or in non increasing order. Okay, so for this video, in this program, we'll do the increasing order, of course. Okay, we'll be using the selection sort and the merge sort. So let us proceed, I think. So as you can see, I have already created the program. You can see here the block of code, okay, in our NetBeans IDE. So the only thing I'll be doing for now, for today's video rather, I'll be explaining to you every line of code you can see here. Okay, you can see on your screen. I will try my best to explain, and also of course the output, so that you would understand. So first, let us know the import java.util, that asterisk. Okay, so this line of code, this statement, I imported the whole package. Okay, not only a single class, but the whole package. When we are importing the whole package, we can identify it as the whole package because there is an asterisk there. Okay, because in importing packages, we can import a single class or a specific class, like for example, import java.util.scanner, import java.util array. However, I chose to import the whole package because I will be using, I have used the arrays and the scanner class. However, I will not really show you, or I will not further discuss about the arrays, the array class. I only use the array class because I prefer checking the content of the array, or I prefer checking the elements of the array using the arrays dot to string. Okay, so that is why I am used to importing java.utility package, the whole package, not a single class. Okay, so the question is, why are we actually using scanner in our class right now? So I think you can already assume that we're going to do a user input here. Okay, we're going to implement a user input in this program. Okay, so we'll be asking our user the size of the array, of his or her desired size, the unsorted elements, and so on. Okay, we'll be seeing those later on. So let's just proceed now for our public class sorting algorithms. Okay, so as you can see, there is an access modifier public there in our class sorting algorithms, meaning to say this is our main class. Okay, when a class has a public access modifier, meaning to say it is the main class. Okay, and another indication that class is a main class is that it has the same name with the file name. As you can see, the file name and this class have the same name. Okay, so meaning to say this is our main class. excuse me. Okay, so I just included that info, so that you are aware of why there is a public there, of why there is a static there, why there is a private, and so on, right? Excuse me. So now let us proceed with the methods that we are using in this program. Okay, methods that perform operations on our program. Okay, operations like sorting. Okay, mainly sorting, not only like, mainly sorting. The selection sort, the merge sort. Okay, of course we're using methods. Okay, later on these methods will be invoked or called, and they will perform operation. Mainly sort to sort, unsorted elements. So here it is in our selection sort. Okay, we have modifiers public and static, an access modifier public and a non-access modifier static. Okay, meaning to say, since it has a public access modifier, our selection sort method is accessible in all classes, right? And since it has a non-access modifier static, meaning to say it belongs to a class sorting algorithm, and at the same time we can access this, or we can call this without doing instantiation, or without referring to its object, without creating an object. Okay, we can directly call or invoke this method without creating an object. Okay, that's static. That's the use of our static. So in our method selection sort, there is a parameter int array. So meaning to say, we're going to be using the elements of this array. Okay, that is why we made it our parameter. So selection sort, what will the selection sort do, okay, in our program? Aside from sorting, specifically what way of sorting it will do, right? So the selection sort, the thing it will do is that it will point, we will have to actually like set a minimum location or position, or let's say indexed. Okay, for instance, the initial minimum index is the location 0 or the index 0, and then we will be scanning the rest of the elements, okay, to find the lowest value. After that, after finding the lowest value, we will now swap the value that's in the minimum index to the let's say to the lowest value. That's it. That's the thing. Until we will repeatedly do that, or our program will repeatedly do that, or which is our method will repeatedly do that until the array is sorted, right? So let us proceed. So this loop, like for loop, this outer for loop, the thing it will do is that this will be the one will point who will point to the index. Okay, it will point to the index. First, it will point to the location 0 index. Second, it will point to the index 1. Third, until last, right? So that is the use of this. Okay, so next, this for loop, the thing that this for loop will do is that it will like find the lowest value, and that lowest value will be stored in our minimum index. The position of the lowest of our lowest value will be stored in this variable minimum index. And then right here in this block of code, the value that's in the the index that we are pointing, okay, and the lowest value will be swapped through this block of code. As you can see, there is a temp there, meaning to say temporary container or variable. Okay, when it comes to swapping, we will need, of course, a temporary container. Okay, a real life let's say example or situation for that. Okay, or explanation rather of why we need a temporary container when swapping is, a can of, or let's say a bottle of water and a bottle of Royal. Okay, and for us to be able to swap the two, okay, for us to transfer the Royal to the container of the water and the water to the container of the Royal, we will need a, let's say, an empty container. So the first thing we will do is, it's either we'll put the water to the empty container or put the Royal first to the empty container. It's up to us. So for example, I'll be putting the water to the empty container. So meaning to say the container of the water is now empty. And since it is empty, we will now put the Royal to that empty container of water. And then, now that the container of the Royal is empty, we can now put the water to the container of the Royal. In that way, we have swapped the two, right? So that's it. That is why there is a temporary container there. It's just the same. It's just that it's just a real life, like explanation of why we need a temporary container. Because in that way, we are able to swap. Okay, so that's it. That's it for selection sort. So now let us proceed to our merge sort algorithm. Okay, in our merge sort algorithm, we created two methods. One for the merge, and the other one is for the sorting. Okay, other one is the main function of our merge sort algorithm. Okay, so from the word merge, okay, the use of this method is to combine. Another term for merge is to combine, right? This will combine two subarrays of our array. Okay, it will merge two subarrays. So the first subarray is the array left to the middle, and then the second subarray is array middle plus 1 to the right. Okay, so this method will merge the first and the second subarray. Okay, because in merge sort, it iterately divides the array into equal halves. Okay, it will iterately divide the array into equal halves until it can no longer be divided. That is why there are subarrays. Okay, that is why there is also merging. Okay, when the the subarrays are already sorted, we can now merge them, we can now combine them. Okay, so that we can get the output. Of course, we can get the sorted array output. Okay, after using the merge sort algorithm in sorting those elements. Of course, we have here the parameters int array, int l, int m, and int r. So the int array, of course, we put it as a parameter in our merge method. It's because we will be using its methods, right? And then this is for the left, this is for the middle, and this is for the right. Okay, excuse me. So now this block of code are used to find the sizes of two subarrays to be merged. Okay, through this formula we'll be able to find the size of our first subarray, and that size will be stored in our N1. Okay, and this one is for the second subarray, which is the right minus middle. Okay, and the size this size for the subarray, for the second subarray, will be stored in our N2 variable. Okay, and these two variables will be specified in our temporary arrays. Of course, we created temporary arrays here. We have the L array and the R array. L for left, R for right. Okay, we specified here its size to N1 and N2 for the right. Okay, this is the creation of new array. However, creation of new temporary arrays. Okay, so next is this block of codes. Okay, what are the use of this block of codes right here? Okay, as you can see, there are comments there, so that we can identify the use of this. Okay, they are divided with their functions. Okay, so this block of code is used to copy data from the array, which is the int array, to the temporary arrays. We'll be copying the data from our arrays to the temporary arrays L and R. So next is we'll be merging the temp arrays, of course. After sorting the temp arrays, we'll be able to merge them through initializing first indices of first and second subarrays, and of course this block of code. Okay, through this block of code, we'll be able to merge our temporary arrays. Yes, we'll be able to merge them, and in merging, we'll already be putting them in our array. Okay, so that's it. So this block of code is, used to copy remaining elements of L, if any, and also here is for the R, if any. If there are remaining elements, this block of codes will be used if there is any remaining. If there is no remaining, then this block of code will not be executed. Okay, so this this block of code, the use of this will be further discussed, or we'll be able to understand this more later on with an example, through our example rather. So here is the main function of our merge sort. Okay, this sorts the array left and the array right. When we say sort, it will arrange, right? Okay, so we have here the parameter int array, int L, int right. Okay, so through this one, we'll be able to find the middle point. Of course, we will be finding the middle point because we are dividing, right, the array into half. Okay, and we're able to do that through finding the middle point. And it is not our first time to actually see this formula or see this block of codes, because we have encountered this in our binary search, right? We're also finding there the middle point. So we are familiar with L plus R minus L divided by 2. Okay, just saying actually. So next, this block of code sorts first and second halves. Okay, it will sort the first and the second halves, and this one merge the sorted halves, right? So this one, in this one, we sort our first and second halves. After sorting, we'll be able to merge those sorted halves through calling this merge method, which is this one. Okay, so we'll further understand this block of code later on through an example. So now let us move on with our main method. Again, in our main method, it is where we put or place block of codes that are to be executed. Okay, it is where we put our block of codes that are to be executed or to be performed. Okay, in our method, that's in our main method. It is where it is our driver code, and it is where our compiler starts reading. And actually I think I don't have to further discuss it because I've been repeatedly mentioning about it already in my videos. So now let us just proceed to our scanner class. Okay, of course we can use our scanner class because we have imported the java.utility package. Okay, so the certain thing or the function of this class is that it will read the inputs from the user, right? We'll be able to read, our program will be able to read the input from our user through this scanner class, of course with the use of its methods, and we'll be able to access its methods through this object. Okay, this is an instantiation. Okay, we're creating an instance of our class scanner. So next is, this is for space purposes, of course, for organization of our code, of course, of our output. If we wanted our output to be decent looking, right, organized, then we'll have to, of course, put spaces. Okay, so right here, this statement will prompt to the user to enter size of array. Okay, this will ask the user to enter size of array. Okay, and when the user enters the size, this will, next int method from the scanner will read that. Okay, and that will be stored in our variable size. Whatever size the user will enter will be stored in our size variable. So for example, the user will enter 5. Okay, the size that the user enters is 5. So now we have a size of 5, and then we created an array. Creation of new array, and with size, of course we put the size, we specify the size here. So assuming we have put there 5, so the size of our array is 5. Next, this is for space purposes again, and then this statement will prompt user to enter size unsorted elements. Of course, not literally, it will not literally print on screen enter size. It will print enter 5 unsorted elements. Whatever size the user have entered, it will prompt to the user there. Like, for example, the user have entered 5 as the size of the array. So this will prompt to the user enter 5 unsorted elements. When we say unsorted elements that not in decreasing order, there is no order. It is randomly placed or positioned. Okay, and that will be read by this block of code, of course. Okay, so next is, as you can see, I have here a comment of arrays.toString. As I have said, I am used to checking the content of the array through arrays.toString because I think it is more convenient, and it is much faster for me to look at its content or the elements inside of our array through through the arrays.toString. Okay, then the loop. Okay, look at that. It only took 1 line, and our loop took 3 lines, right? So now let us proceed. This will, of course, but let us just ignore that. Okay, we'll not be using that in our program. That is why I made it as a comment. I just mentioned about it. So now this is for space purposes, and this will set as indication to the user that the following output are the elements before sorting, which are the elements that the user have entered, right? Those are the elements before sorting. elements that were still not sorted, okay, that were not yet still sorted, okay, and those will be printed out using the for each loop, of course. So now this block of code, of course, will create spaces, and then let us proceed to this. Okay, finally, a function or a method has been called or invoked, which is the selection sort, meaning to say it's time to sort the element from our array using the selection sort. So we'll now go to our selection sort. Okay, let's act like a like a compiler. Of course, when it is called, the selection sort will be performed. Of course, the compiler will read this block of code, right? So of course we have, for example, okay, before we go there, let's just assume that the user have entered in our here the like 3 2 5 9 8. Okay, as if, okay, the user have entered 5 elements, of course, because I have also mentioned that as if, or assuming the user have entered 5 as his or her size for the array. And we have here like assuming also this one, 3 2 5 9 8 1 2 3 4 5. Okay, this is the array, this is the elements of our array. So we'll just go there in our selection sort, of course. Okay, it is for much better understanding, for you guys to understand more our program. We will need example, like actual example. So we have here the for int I equals 0. Since 0 is, let's put here like as if this is the elements of our array. Since 0 is less than array.length, which is 5 minus 1 here, which is 4 now. Since 0 is less than 4, let's put here 4. Since 0 is less than 4, 0 will be put in our variable minimum index. Okay, 0 is our minimum index. Okay, because I has a value of 0. Okay, it has an initial value of 0. It is our minimum index. As I have said in selection, we will set the minimum index or location or position to location 0. Now, we will find the lowest value. We will scan through this block of code. J equals I, which is 0 plus 1, which is 1. Since 1 is less than array.length, which is 5. Since 1 is less than 5, let's put 5 here. Since 1 is less than 5, we will have to go through this. Okay? So array j, which is 1, index 1. Now our index 1 is 2, right? So we'll have to compare if 2 is, this one is the index 0, element in the index 0. So let's check if 2 is less than 3. Since 2 is indeed less than 3, we will put the position of the 2 in the minimum index, and the position of our 2 is 1, right? So we will put 1 as our minimum index. Okay, then increment. So from 1 it will become 2. Since 2 is less than 5, okay, we'll have to go to this. So array j is now 2, which is 0, which is 5. And then we will check, or let's compare if 5 is less than 2. Since 5 is not less than 2, we will not put 5 in the minimum index, of course, right? So next is increment. So from 2 it will become 3, and 3 is less than 5. So we'll check, the 3 is 9, right? 9. Since 9 is not less than 2, since 9 is not less than 3, rather less than 2. Since 9 is not less than 2, we will not put the 9 in our minimum. We will not put the position of 9 in the minimum index. Okay? Increment increment 3 to 4. So 4 is less than 5, so we'll check. So 8 is not less than 2, so we will not put the position of 8 in the minimum index. So the minimum index will stay the same as 1. Okay? Which is the 2, right? The position of 2. Increment 4 to 5. So 5 is not less than 5. It is equal to 5. So this loop will be terminated. And we will now proceed to here, to swapping. So array min index, our array min index is what? 2, right? Yes, our 2, our lowest value, we will store that in our temporary variable. And then our element of our index 0 will be put in place of the position of the previous position of our lowest value. And then our lowest value now will be positioned to the index 0. That way they're already let's say they are already swapped. Okay, their positions are already swapped. So now 2 and 3 are swapped. So 2. So now the 2 is already in the index 0. 5, 9, 8. Right? So next, increment. So from 0 it will become 1. Excuse me. And 1 is less than 4. Okay? Since 1 is less than 4, this block of code will be performed or executed. So 1 will be stored as the minimum index 1. Let's put 1 there. Okay, let's check. 1 plus 1 is equals to 2, right? So 2 is less than 5, right? So we'll check here, array 2. So 0 and 2. Since 5 is not less than the 3, right? 5 is not less than to 3, so we'll not put 5 in our minimum index. So increment. So from 2 it will become 3, and 3 is less than 5, so let's check again. So 5, so 9 is not less than the 3, so we will not put the 9 to our minimum index, the position of 9 to our minimum index. So increment. So from 3 it will become 4, and 4 is less than 5, so yeah, so 4, which is 8, is not less than to 3, so 8 will not be put in our minimum index, right? Okay, so our minimum index will, let's say it will stay the same. It will stay the same. So now we will we will increment. So from 4 it will become 5, and 5 is not less than 5, it is equal to 5. So terminate, and we will now move on here. Okay, so what will happen is array min index is still 3, right? So it's still the same, so we no longer have to like let's read this. Okay, 2 and 3 are already sorted. So now let us increment. So from 1 it will become 2. So now our minimum index is 2. Okay, we're now pointing to our 5, the position of our 5. And then let's do this. So from 2 plus 1 is equal to 3. So 3 is less than 5. So 9 is not less than 5. So we will not put 5 in our minimum index. So increment. So let's say 4 is not less than 5. So let's say 8 is not less than 5. So we'll not put 8 here. So increment, it will just 5 is not less than 5, it is equal to 5. So terminate. Okay, it will just be the same. 2, 3, 5 are already sorted. So we'll not read this already. Okay, let's not read this. Okay, so now let us increment. So from 2 it will become 3, and 3 is less than 4. Okay, let's go here already. So 3 plus 1 is equals to 4. 4 is less than 5, right? So we're pointing already to our 9, right? It is in the index 3. That is why we're pointing to 9. So that's it. So our 4 is less than to 9. So that is why our index of our 8, which is 4, will be placed our minimum index. So increment 4, which is 5. 5 is not less than 5, it is equal to. So now this loop will be terminated. So now we have here array min index 4, which is 8. So 8 will now be placed over temporary container, and our array I, which is 9, will be put in the previous position or location of our 8, right, of our lower value 8. And then our 8 will be placed to the position of the previous position of our 9. So it will now become 2, 3, 5, 8, 9, because now the 8 and 9 have switched. Okay, so terminate. Okay, it will not let's go back to increment. So from 3 it will become 4, and 4 is not less than 4 but is equal to, so the whole loop will terminate. So as you can see, we just did right because we have already sorted the elements from our array. So from 2, 3, 5, 9, 8, it became 2, 3, 2, 3, 5, 8, 9. 2, 3, 5, 8, 9. It is already sorted. Now let us go back to our main method. Now that we have already sorted, now that our selection sort have sorted our array, so it will now print sorted elements using selection sort, and it will be printed using the for each loop. Okay, it will print the this one. Okay, this will print this one, 2, 3, 5, 8, 9. So now next is this will print space, of course. And now another method is called or invoked, which is the merge sort, another sorting algorithm. Okay, so now since it has been called, we will now go to that method, right? Because it will perform a certain operation. And in that method, we have here the array, which are the elements that will be accepted by our parameter in the array, and then 0 as our argument for that will be accepted by our parameter L. Array.length -1, which is 5 minus 1 equals 4. that will be accepted by our right, okay, our parameter. Okay, so here it is. We will go there in our merge sort, of course, in our merge sort. Here is our merge sort, and in our merge sort we have this block of code. Let's check. If L is less than R, our L is 0, right? And 0 is less than 4. Since 0 is less than 4, this block of code will be performed or executed. Of course, first, since we're talking about merge sort, we'll have to iteratively divide the array into equal halves. Okay, and we'll be able to do that by finding the middle point. We'll be able to find the middle point through this formula. So r minus 1, which is our r is 4. 4 minus 0 is equals to 4, right? And 4 divided by 2 is equals to 2, right? 4 divided by 2 is equals to 2, and 2 plus 0 is equals to 2. So we have here the middle is the index 2. Index 2 is our middle. Let's put here our let's go first this one. Our middle is the index 2, which is the 5. 5 is our middle. It's in index 2 because it's in index 2. So that's it. Our middle is the index 2, which is 5. And now we will sort first and the second halves. We will sort the first halves and the second halves. Okay? And we'll be able to do that through array and then left to the middle. We will sort the 3 to 5. It is our middle, right? So we'll sort that. So from 3 to 5, it will become 2, 3, 5. Okay? And then, what about for our 9, 8, right? 8, 9, 8. For our 9, 8, okay, for our 9, 8, it will become what? M plus 1, which is 9, and then the right. So we will sort that. It will become 8 and 9. Like this. 3, 2, 5, 8 now. So now they are already sorted. Okay? The left, the first, and the second halves are already sorted now. So now that they are already sorted, let us now merge them. And we'll be able to merge them through calling the merge method of our merge sort. Excuse me. So merge. So we are calling the merge, so it will perform an operation and we'll go to there. We will go there. Okay? Which is this one. Let's just copy this. Just copy this. We'll go there in our merge method, and then of course we'll find the sizes of the two subarrays to be merged. Okay, our two subarrays are the left and right. Okay, that left to the from left to the middle, and then the m plus 1 to the r. Right, those are the two subarrays. So here it is. Here is the size of our first subarray, and here is the size for our second subarray. So middle minus L. So our middle is 2, right? So 2, index 2. So 2 minus 0 is equals to 2. 2 plus 1 is equals to 3. So the size of our first subarray is 3. So that will be stored in our variable n1. And for our second subarray, r minus m, which is 4 minus 2 is equals to 2. So that will be stored in our n2. And these two variables will be specified in our temporary arrays. Okay, n1 for our L temporary array, n2 for our R temporary array. So these are creation of new temporary arrays because these are temporary arrays. So that's it. We've already specified their let's say sizes, right? So this has 3 and this has 2. So now let us copy the data to temporary arrays. Let us copy the data from our array to our temporary arrays, right? So what we will do is that okay, int I is equals to 0. 0 is less than 3. Let's put 3 here. Okay, because it's the size of our n1. So since 0 is less than 3, we will put the 0. Okay, 0 plus 0, which is array 0, which is 2. We will put that in our array. Okay, we'll put that in our L array. Next is increment. So from 0 it will become 1, and 1 is less than 3. So now is the 0 plus 1, so which is the index 1, which is 3. So we'll now put the 3 in our L array. So next is the increment. So from 1 it will become 2, and 2 is less than 3. And now the 2 is 5. We will put the 5. That's it. So 2 plus 1 is equal to 3, and 3 is not less than 3 but is equal to 3. So terminate. Now we have put the 2, 3, 5 to our temporary array L. So this is our left side. So next is for the right, or for the R. Since 0 is less than 2, this is 2. Since 0 is less than 2, our M, which is a middle, 0, 1, 2, 2 plus 1, which is 8, plus 0. So our 8 will be stored in our R array. So next, increment. So from 0 it will become 1, and 1 is less than 2. So that's it. Middle is 2. Middle is 2 plus 1 is equals to our middle is 2, and plus 1 is 3. So 3 plus 1, it will become 4, which is our 9. So our 9 will now be stored in our R temporary array. So that's it. We have already copied the data from our array to our temporary arrays. Now let us move on to merging the temporary arrays. We will now combine our temporary arrays. Okay, and we're able to do that by initializing the indices of first and second subarrays. Of course, the initial index of our first is 0. The same with our second subarray. So now, right here, through this we'll be able to merge the two temporary arrays. Okay, temporary or subarray array. So now we created a variable of k, and we have stored there L that has a value of 0, and I should be less than n1, and also j should be less than n2. So I should be less than 3, and j should be less than 2. Okay, so since I, which is 0, is less than 3, and also 0 is less than 2, this block of code will be performed. So li, which is 0, the index 0 of our L temporary array, which is 2, will be stored in our array. Okay, that will be stored in our array. So now increment, so from 0 it will become 1. So now we have 1, right? 1 is less than n1, right? So 1 is less than n1, right? 1 is less than n1 because our n1 is 3 and 1 is less than 3. So this will still be performed or executed. So li is equals to index 1, which is 3. So meaning to say 3 will be stored in our array. Okay, then increment 2. So 2 is less than 3, so this will still be performed or executed. Okay, so that's it. So L2, so 2 is less than okay, so I paused for a bit because there is noise, okay, disturbance. Okay, let's continue. So we have now 2 and 2 is less than 3, so this block of code will still be executed. So L2 index 2 of the L temporary array, which is the 5. So 5 will be stored in our array. Okay, so 2 increment will be 3 and 3 is not less than 3. Okay, so meaning to say we'll go to else. Okay, we'll go to else. And now our 3, okay, so we'll go to else, which is the 3, which is the 8. Okay, it will be stored in our array. Increment, so from 0 it will become 1. And you know, 1 is no, 1 is less than 2, right? And that is why our 2 will be stored, our 1, which is 9, will be stored in our array. So from 1 it will become 2, and 2 is not less than 2 but is equal to 2, so this will be terminated, right? 2 is less than 2, 2 is not less than 2 but is equal to 2. So nothing already is less than, so terminate. So now we have already, excuse me, okay, so we have already stored the 2, 3, 5 and 8, 9 to our array. We have already merged them, okay, the 2, 3, 5, 8, 9 to our array. Okay, so now let us check if there are remaining elements. However, there are no remaining elements, meaning to say we no longer have to perform this, we no longer have to execute this, okay, because this is only used for copying remaining elements of L and also write if there is, or if any. Okay, however, there are no remaining elements, so let us continue. Let us now go back to our main method. So now we have already sorted our array. Okay, so our, let's say our array now has 2, 3, 5, 8, 9, right? Because we have all stored them now in our array, right? So we have now we now came back in our main method, and we now this will now print out just sorted elements using merge sort, and through this loop, this will be printed. The 2, 3, 5, 8, 9, the sorted elements of our array. And of course, next to that is this space right here. And also we just close our input, okay, our class scanner. Excuse me. So now that we're finished with our program, of course, explanation, we're finished. I have finished rather. I have finished my discussion of every line of code in my program. Now let us take a look at the output. Okay, let us take a look at the output. Okay, let's take a look at the output, of course. So enter size of array 5, enter 5 unsorted elements. Let us try copying our example. Let us see if we have the same answer, right? We have the same output. So 3, 2, 5, 3, 2, 5, 9, and 8. Okay, let's see if we have successfully accomplished our program. So as you can see, we have here the enter size of array 5, enter 5 unsorted elements, 3, 2, 5, 9, 8. These are all unsorted. These are unsorted elements. And now we are showing our elements before sorting, the 3, 2, 5, 9, 8, and now they are all sorted. Okay, sorted elements using selection sort 2, 3, 5, 8, 9, and also sorted elements using merge sort 2, 3, 5, 8, 9. So we have accomplished our program, right? We have successfully done our program. Okay, so we have implemented the user input, in which we ask the user to enter size, enter enter sorted elements, and also we have displayed the sorted elements, okay, from the inputted unsorted elements of the from the user, right? Okay, so let us go for another example. Okay, let's go for another, no, not another example. Let's go for, let's run the program again. Brother, not example. There's no other example. Let's just run the program. Okay, so enter size of array, for example, 10. And then unsorted elements 4, 7, 3, 1, 0, 5, 7, 6, 8, 10. So now let us see what will happen. As you can see, enter size of array 10, 10 unsorted elements before sorting, and then now they are sorted using selection sort 0, 1, 3, 4, 5, 6, 7, 7, 8, 10, 0, 1, 3, 4, 5, 6, 7, 7, 8, 10. Okay, I think we have successfully accomplished our program, right? I think let us run our program for the last time, okay, to finish our video. Let's run the program for the last time. Okay, so enter size of array like 6, 4, 8, 5, 1, 2, 6. Okay, now we have enter size of array 6, enter 6 unsorted elements, and so on, 1, 2, 4, 5, 6, 8, these are sorted elements already. From unsorted, we have sorted them using selection sort and merge sort, and yes, we have accomplished our goal. I have already discussed the block of codes of our program, and also I have showed you the output, okay, that we have. I have created a program well, okay. So I think that would be all for our discussion, okay, for our program, for the creation of our program, okay, for our discussion, of course. Thank you very much, and I hope you guys have learned a lot from this video. See you again next time. Thank you. Bye.